Hi guys, BuildZoid here, and today we are going to be taking a look at this card right here, as well as some oscilloscope measurements that I've taken from this card. So this is a MSI GTX 770 Lightning that I picked up on eBay as 4 parts or not working. Or is it 4 parts and not working? No, it's or not working, yeah. So anyway, I picked it up as a 4 parts card because I was bored and I wanted to try repair something. And then I got really lucky, and this was actually super easy to repair, and so yeah, that was really like there's no repair video of it because it was too easy, and it didn't make sense to make a video about it. Anyway, we'll cover the repair in this video also. But the thing is, what's really interesting about the GTX 770 Lightning, GTX 680 Lightning, and the 7970 Lightning, possibly some other Lightnings, I'm not sure how many Lightnings actually ended up having a GPU core reactor, but yeah, it's the GPU core reactor. This is really interesting because this right here is, I'm going to take it off, but I don't want to show you the card. So that right there is the GPU core reactor, as MSI calls it. And it's basically a little, just a PCB with some LEDs and some capacitors that connects right behind the GPU core using those two connectors down there. So the idea obviously is that this is basically a little sort of, well, it's basically just extra output filtering for the vCore VRM. That's what it is. And it also has LEDs because everything has to have LEDs so that people know that it's working, right? Um, like it basically there'd be like a plastic cover over it with an MSI logo, so the LEDs would light up the logo. But yeah, I think the LEDs were dumb. I think they should have just used the connectors just for capacitors, nothing else. But anyway, so this is really neat because yeah, we've got these little capacitors on this little board. It goes right behind the core, and so at the time that these cards would get reviewed, basically this would get taught like this. This was by most people, as far as I know, considered basically to be a pretty silly little gimmick that the cards came with that made it impossible to run them in quad GPU setups because your GPU was now 3 slots thick. But it wasn't because the heatsink was bigger, it was because the back of the card had this bulge with capacitors in it. Because there's the plastic cover. Now, I don't have the plastic covers because, in my opinion, they're stupid. I'd much rather have the naked capacitors. I much prefer those. And also, the plastic cover looks really cheap, and it's blue, and like the rest of the card is yellow, and I just don't think it goes together very well. Like the LEDs are still blue, but the cover being blue doesn't work, in my opinion. But whatever. Yeah, it's basically just capacitors on a little PCB, and then it has these connectors. And so what I was wondering was, like, how effective is this? And how bottlenecked is it, if at all, by these connectors, right? Because the thing that I've, like, really wondered about is, like, these are low impedance capacitors. Like, these are SMD aluminum polymers, 470 microfarads each. I'm going to assume from Panasonic. Then we've got these 10 microfarad multi-layer ceramics in an 0805 package. Like, these are some very low impedance capacitors. Like, they can't be doing that great a job going through these connectors, right? Like, come on, these connectors do not look like they'd be doing, these have to add a lot of ESR and ESL to the connection to the capacitors compared to just adding extra capacitors to the power plane of the GPU itself. So, you know, well, I still want to hide it. So I'm just gonna throw that back on the card. This is actually really annoying to install. It's one of the biggest complaints from like overclockers for the reactor is that if you install it wrong, and you can install it wrong, it actually will kill the card if you power it on while it's installed wrong. So, and it's not exactly, like technically the connectors are keyed, but it doesn't work. Like the keying of the connectors works a lot better on paper than it does in practice. And come on. There we go. Got it back together. Like I have these like Sharpie marks on there to try help with the alignment, but yeah, it doesn't help. So anyway, I attached a little oscilloscope, like twisted wire pair to this sort of connector so that I could hook up the oscilloscope probe. And that twisted wire pair goes just to a capacitor right behind the core. And the idea is let's just measure how much well, let's just take voltage measurements with the card running 3D Mark Firestrike with the reactor installed and without the reactor installed and see how much of a difference I can measure. And then also, because I actually have two of these reactors, because I also have a GTX 680 Lightning, and that one is in like perfect condition. This was a card I repaired, so at that point, it's like I'm far more willing to do things to this card than I am to my other 680 Lightning, which is like that's a real that's a great condition card. This thing, not so much. I mean, it's not like the repair wasn't that serious, but at this point, it's like, yeah, this is not a new 770 Lightning, so or even like new 770 Lightning. So at that point, it's just like, yeah, whatever. So I tore down the capacitors off of this one. This is actually the reactor for the 680 Lightning, but the same PCB, same reactors, same everything basically between the two cards. So I pulled the caps off of the reactor because I wanted to see if attaching the caps to the card would actually make them perform better. And yeah, and then I of course tested with the reactor and without the reactor installed. So let's pull off the reactor, and that's what the card looks like without the reactor. So I've added, so the little 10 microfarad, well, not all of them, but some of the 10 microfarad multi-layer ceramics that the reactor comes with, I've managed to jam right behind the core. I'm kind of disappointed that these caps are just 10 microfarads. Asus for the 290X Matrix, which isn't really that much older than this card, actually used 47 microfarad caps right behind the core, like multi-layer ceramics, same package size, 0805. That's actually the highest capacitance you can get in an 0805 package as far as I'm aware, at least if you also want like decent temperature tolerance. I didn't really look into like low temperature tolerance capacitors at all. But yeah, so I whacked those right behind the core. And then, of course, the aluminum polymers, well, you can see some of them right here, but I managed to sneak those onto the card really nicely. And that's kind of the thing that I try to do with a lot of... Like, if I have a nice card, then, and I decide to do mods on it, then my goal with the mods is to make them as stealthy as possible. So as to not have them... Like, well, basically, I want the card to not look like it's not modified until you take it apart. That's my goal when doing cap mods on some cards. Like, there's other cards where I'll just have the caps sticking right off of the back because the PCB isn't actually that nice, or they don't come with a back plate or whatever. But yeah, this is a really nice card, so I wanted to keep it sort of looking like nothing happened. But a lot happened. There, that's what happened. So, it looks like there's a lot more, like I added a lot more caps than I actually did. Well, actually not a lot more, but like it looks like I added more caps than I did. But the thing that's going on here is actually there's one cap at the start of each of these rows. So this cap is original. That cap was already on the card. This cap was already on the card, so that's why I connected directly to those, because it's like, well, that's the most convenient place to connect. I would have preferred to just stack them right behind the core, but those plastic connectors for the reactor are just impossible to work around. Like, I melted this one kind of bad. Like, I've slightly melted this one while adding the little multi-layer ceramics, and desoldering these, like, no, I'm not doing any large-scale soldering right behind the, well, actually, that's not true. If it weren't for the little plastic connectors, I would do large-scale soldering right behind the core, but yeah, no, not with that plastic there. It's just impossible to work around it. So, yeah, so I added the multi-layer ceramics because that was relatively easy. And then I added, then I did this row right here. The reason why this doesn't extend further is because of the way these, there's this point right here, and unfortunately this side of these caps is ground, so if I go over that, it's going to short out. So, yeah, can't go there. Then the wires are just to try reduce the impedance to the extra capacitors, because, like, I'm now using the connection for like one capacitor to connect way more capacitors, and so I figured, yeah, this is probably not ideal. And yeah, so I managed to get all the aluminum polymers onto the card. I did not get all of the multi-layer ceramics. Like, you can see that I have 4 still on the reactor, and actually there wasn't enough space to get every single one of the other ones that I did desolder. Like, there was one left over after I finished soldering. So yeah, I didn't manage to get all of the caps onto the card. But funnily enough, this right here is actually less effective than the reactor. So yeah, apparently these connectors actually aren't that bad, which really, really surprised me. I thought like the connectors have to be like a huge compromise, and you know, like they're chewing up a ton of the performance of the caps. There's also a chance I cooked these capacitors when desoldering them. Like that's also a possibility. Like I might have roasted the crap out of them, and their ESR and ESL. Well, mostly ESR is probably could be much worse than it's supposed to be, but the thing is with the reactor, like that's a low. Like this is a low heat. Like the PCB doesn't have a lot of mass to it, so it's not like I was going super high temperature to pull them off. But yeah, I don't have a cap tester, so I don't know what condition they were in after I pulled them off. So that's kind of annoying. But yeah, let's just take a look at the results. So I managed to fit these on. So like, and the thing is, they're so well attached that like you can still fit the backplate and everything. So you can't even really tell they're there until you remove the reactor. And then the oscilloscope probe is just a twisted wire pair. And here, like this is not ideal most of the time. But here, the thing is, we're testing one card, especially since this twisted wire pair is as long as it is. But I had to have it this long just to get under the reactor and then out the side. And because if I measured from the reactor, well, that's useless. I need to measure from the card with and without the reactor. So can't measure on top of the reactor. And I don't want to measure from the VRM because this is a mile away from the actual core. So the measurement you get, like if you measure here, you're going to see a lot less voltage spikes and dips than you measure right over here. So yeah, that's why I measured, and I intentionally also measured, like I didn't solder any caps directly on top of the caps that were already on the card because I didn't want any extra capacitance hanging directly off of where I was measuring off of, because that would obviously smooth it over more than it maybe should. So yeah, technically I could still fit two more of the 10 microfarad caps from the reactor. The thing is though, at this point what I'm really thinking about doing is not more 10 microfarad caps. I'm thinking I'm going to put 22, like I have 0603 22s, I have 0805 47s, but the 47s at this point I don't think will fit. Like basically I'm thinking I'm going to keep stacking caps until the reactor stops. And this time I installed it wrong. Yeah, see, that's the thing. And the reason why the keying doesn't work is the plastic of those connectors is very soft. So what happens is if you push down with enough force, you're just going to force it into the connector, even if it's not correctly keyed. Yeah, there's a lot of space under there. Well, can you? Yeah, no, I can't angle it. I can't angle it so that you can see under the reactor, but there's enough space for definitely 0603s. I might even be able to get an 0805 up there, but yeah, like I'm thinking more caps, more better. So I'm probably going to add some more capacitors to the ones that I already added, because the card, like the thing is, I can still fit the reactor, right? So not only did I run the card with the like no reactor, no cap mod, then no cap mod, just reactor, then just cap mod, no reactor, and because I have the extra reactor, I also ran it with the reactor. And even after this, because the thing is, this actually doesn't work as well as the reactor. Even after this, the reactor leads to better voltage regulation, which makes me think more caps would still help further. Like, that's the thing. It's like we can still keep adding capacitors behind the core, and it's going to keep helping, because like this thing still has a measurable benefit. So, obviously, there's not enough capacitance behind the core. Anyway, also the repair. So the repair on this card is just this right here. Essentially what happened with the card is, for whatever reason, I assume that somebody probably just like bent the card, or the backplate shorted out against them or something like that. But basically there was two little input filtering inductors for the 3.3 volt rail. Both of them were exploded, so I removed them and replaced them with a jumper. And you might be like, isn't that a bit of a problem? You replaced inductors with a jumper? Well, they're input filtering inductors. They don't matter that much. I wouldn't replace other things with a jumper, okay? Like if you have a V-core inductor die and you replace it with a jumper, you're going to have a very, very bad day. For about a couple seconds before you realize you just permanently destroyed the silicon. And at that point, it's like, well, fun fact about most GPU repairs, the silicon is worth more than the rest of the card. So if the silicon's dead, you can basically get rid of the entire thing. So Yeah, that's kind of the thing. Like the jumper here, this is fine because this is just input filtering. It's not that important, especially since it's 3.3 volt input filtering. Like, it's the 3.3 volts. It doesn't do like it's a really low power rail. This is not a big deal. If it was anywhere else, this would kind of be a problem. Also, I obviously checked that there was no short circuits on the other side of the blown up inductors before I decided to replace them with a jumper, right? Because if you see an exploded component, sometimes that's not the thing that killed the card, that's just the symptom. So you have to check that whatever exploded doesn't have a short circuit after it, or like before it, or like, because, yeah, you need to check for shorts. So check for shorts, and then put the jumper, and then card works. So card works just fine. Actually, it's now run multiple hours of 3D Mark Firestrike because of, like, I initially tested it after I repaired it, and now, with the mods, I've been testing it as well. So yeah, the card's perfectly good at this point. Let's talk about results. So let's talk about how the mods worked. So here is the lovely spreadsheet of the various results. So we have the card running just Firestrike GT1. These are stock clocks. This is just what it comes at. I didn't bother with any overclocking because I also want to do some comparisons against a GTX 770 classified that I have. I got that as a extra with a bunch of HD 7990s that I bought ages ago. Yeah, anyway, and I haven't done, well, I tested one dumb idea on those on one of the 7990s. I have a lot of plans for those though. Anyway, so yeah, I'm just running it as stock clocks here because I don't really want to deal with like applying profiles or whatever. And also, like, I am very confident in the whole, if the minimum voltage goes up, then the overclocking capabilities have improved because, like, well, I've tested that a couple times that actually works. And funnily enough, like, GTX 680 was like one of the first cards I cap modded, and like, well, that was not a lightning. It was nowhere near as nice as this card, but it was very strange because I think I ended up with a card where I added something like 20,000 or maybe even 30 or 40,000 microfarads worth of extra capacitance to the output of the VCore VRM, and it kept improving in terms of max stable overclock, which was really dumb. And then I killed the card with way too thick thermal pads. Good job, me. Still wasn't as nice. Like, it was just a regular 680. Yeah, regular 680. So it wasn't like a huge loss in my opinion, but still a loss that was kind of annoying. Anyway, yeah, so we've got 1.2 volts out. So the scope VCore, that's just average voltage. All of these measurements are taken at 5 milliseconds time scale, 60 millivolts voltage scale, and DC coupling, 20 megahertz bandwidth on a 10x probe that has, I think, 150 megahertz bandwidth, but the scope's limited to 20. Anyway, so we have 1.21 volts average, minimum average voltage. Well, the average minimum voltage is 1.14 volts. The absolute minimum voltage is 1.12 volts. And this is just running Firestrike graphics test 1. Temperatures are recorded because actually the operating temperature can affect the measurement results. Like if you're at a significantly lower temperature, the card actually pulls slightly less power, which translates into slightly lower like the transients are less bad. Therefore, your voltage results, or like your voltage regulation looks better when actually it's just like the card's not pulling as much power. Anyway, so yeah, 1.14, so 1.12 absolute minimum. And then peak to peak average was 147 millivolts, and absolute maximum peak to peak was 170 millivolts. And each test was run for multiple minutes before I took the measurement. I basically waited for the average measurement readings to stable, like stop changing, and that's when I took the measurement. And mostly based off of the VPP average, because this one's the one that most floats around. Like the minimum average doesn't actually change that much throughout testing. Anyway, then we have Firestrike GT2, and the results are the same, except the peak-to-peak values are now smaller. So that's kind of that. Then we have the card, oh, and that's with the reactor. Without the reactor, the minimum voltage, the absolute minimum voltage, is 1.1 volts. So 10 millivolts worse, which would, on Kepler, so the annoying thing with Kepler is that Kepler has 13 megahertz clock steps. So if your voltage regulation improves by, the thing is, my scope only does 10 millivolts resolution. So as in it rounds the measurement to 10 millivolts. So like technically this could have been like a 14 millivolt difference or something, and it would still tell you it's 10 millivolts. It could have also been a 5 millivolt difference, and it would tell you it's a 10 millivolt difference. So I really need a better scope for this kind of thing. But yeah, so that I could get the extra digit after the decimal point. Like I need a third digit after the decimal point, but unfortunately scopes with four digits, well, 3 digits after the decimal point on a 4-digit measurement, kind of expensive. Um, anyway, but yeah, so this dropped, according to my not so great scope, 10 millivolts. Which would probably translate to around an entire clock step, which is not a big deal. Which it makes sense. Like, yeah, if you're just doing a gaming build, then yeah, who cares? 13 megahertz, it's not a big deal. But at the same time, if you were running more power, higher core voltage, then the transients would actually get worse. So at a higher level of power draw, this might be slow. Well, I don't think you would go from 13 megahertz to a 26 megahertz difference. Like 26 megahertz is a lot bigger than 13. Like, and the thing is, the power consumption, I don't think your power consumption, I don't think would increase that much to tilt it over. On liquid nitrogen or something, you should actually get a pretty significant advantage because you can easily like double or triple or even quadruple the power consumption of the card. And so then, yeah, it's like something like, because this is 10 millivolts with the card running, I think, right at the 200-watt power limit. So if the card's running like twice as much power, it could, like, I still need to do testing on if it actually scales this way, but you could end up with like a 30 millivolt difference, and that's a big deal, especially if you're benchmarking, because, if you're losing to somebody, like if you're matching somebody on efficiency and you're losing to them by, like 10 megahertz worth of clock speed, that really sucks. So the reactor could make, could literally get you over the edge of getting a top score. Um, so yeah, it makes sense that they had something like this on a lightning card because yeah, without the reactor, the peak to peak on average is 170 millivolts. Peak to peak max is of 210 millivolts, so that's a 40 millivolt increase right there. This is just 20 millivolts increase, though here it's a 30 millivolt increase. It's interesting how the difference is between GT1 and GT2. And yeah, and then the minimum voltage is of course 10 millivolts down, both on average and absolute minimum. So yeah, definitely running without the reactor, it leads to measurably worse voltage regulation. Though in terms of actual like daily overclock stability, it wouldn't really make much of a difference. Anyway, then we have the reactor mod, which so that's this right here, and unfortunately that does not work as well as I was hoping it would. Right? Because we're getting 152 millivolts peak to peak on average. The minimum is the same, so that's good. The minimum is back up where it's supposed to be. Um, and an average minimum is the same. Minimum is the same. But the thing is, again, my scope has 10 millivolts of 10 millivolts of resolution there, so it's like, but is it actually like, because this could be actually 1.124, whereas this could be like 1.16 or 1.15 and no, 1.115 there. So, like this could be, yeah. So this might not actually be as close together as the scope shows it, but the peak to peak value is very close, right? That's just 10 millivolts, just 10 more millivolts. But I'm still surprised that soldering the caps directly to the card is worse than going through the connector. So, like, yeah, I'm impressed. Like, I thought the reactor would just waste most of the benefits of those capacitors on the little connection that it comes with. But no, it doesn't. In fact, it works better than if you try to add the caps directly to the power plane, which, uh, whoa, I guess. Like, I'm really surprised. Um, then again, the reactor connects right behind the actual GPU core, whereas if you look at my card, right at the modified card I have, let me just get the mouse over to it. There we go. Um, like, I'm obviously not connecting right behind the core, right? The core's there. This is the first two caps I added, and then the rest of them is over here. In my opinion, having them all over here is a bit too far away. And I did try to compensate for that with this extra wire here. And then this is just extra ground over here. So this doesn't actually help at all. Well, it could still reduce the impedance a bit, because instead of trying to squeeze all of the current that is coming in and out of these inductors through the pads for the first capacitor, we're now squeezing it also through the pads for these two. But yeah, this is not optimal at all. And then, yeah, like the V core side, like basically I would have much preferred to stack these right behind the core, which in theory should be far more effective. The problem with doing that is those connectors are made of plastic, very soft, and yeah, it's annoying to do. Like they melt, and I'm not going to desolder them because desoldering right behind a GPU core is very difficult to do and risky. And yeah, it's just like I don't want to break the card. I'm very happy that it works. I don't need to kill it again. Not right now, anyway. So let's go back to the results. So me porting the caps to the actual PCB ultimately is not as effective as the reactor, which really surprised me because I really thought those little connectors would suck, but no, they don't. So that's kind of that. Though I did seemingly manage to get to the same level of performance as the reactor, so at least it's not like now I can run the card without the reactor and it performs about the same as without the reactor, whereas before it was like significantly worse without the reactor. But yeah, still, even with my oscilloscope, this doesn't seem to be doing such a great job. And then we have the reactor stack, or the cap mod, which like I consider it now the reactor is like on the card, and then if we add another reactor on top of the connectors, then it's like Reactor SLI, because technically now there's like two reactors, but not really. But anyway, like stacking the reactors I don't think would actually be practical. But anyway, I called it Reactor SLI because that just kind of sounds cool. And that actually further improved voltage regulation, which was really cool from a sort of like, oh, neat, now we might actually get an entire, like if previously it was borderline about getting an entire clock step improvement, now it isn't, because it is literally 20 millivolts more than in the stock configuration, right, on the absolute minimum. Like that is at the very least an 11 millivolt improvement. At the most, it's like a 34 millivolt improvement. No, 24 millivolt improvement, and that would definitely translate to at least a 1300 megahertz core clock 13 megahertz core clock increase. So yeah, this right here is great. Like stacking the reactors is really like it actually works just fine. And that's really neat. And then the peak to peak average just is so low. Like it is absolutely ridiculously low. I didn't think it could get that low. And peak to peak max is just on the floor. Um, like, damn, this really works. This works really well. And the thing is, because the like adding the reactor still like I kind of wonder what if MSI had made like is there potentially a way to make a lower impedance connector for the reactor? Like these are the questions I have now. Is like could MSI have taken this to a step further? Because obviously this works pretty damn well. The main issue with it is, of course, if you look behind the card, is that the reactor connectors block off space for actual capacitors. So that I think like eventually they stopped doing the reactors, and I'm not sure if it's because they came to like maybe they test like I'm not sure if they just decided that it's not worth bothering with. Because from my measurements, it's like no, this is worth bothering with. This is like 10 millivolts better voltage regulation, and I think that's neat. And admittedly, most people probably don't care about 10 millivolts, but if you're doing a crazy card, like if you're doing a lightning card, to me, this is completely justifiable. This is the whole point of a card like a lightning. You do silly things like like a little cap board like this. And so I wonder if they ended up testing with like, I think the 290X Lightning already doesn't bother with the reactor, and then 780 Lightning, I can't remember. But 290X Lightning, they stopped doing the reactor for sure. And I wonder if they actually ended up testing like fully populated with capacitors behind the core versus having the reactor, and which one ended up being better. Because yeah, like I'm kind of sad this went away. Like it is really silly, it's not very practical, but it's cool. Like I'm a big fan of this, especially now that I have measurements showing that this actually works. Also, at this point, what I'm thinking of doing is because this works so well, what if we added even more capacitance to the reactor? I mean, MSI was kind enough to leave these two empty pads for, like, these empty pads for me right here, and also these right here, and those right there. And also, is that actually? No, I think that's for extra LEDs. So yeah, they left a bunch of empty pads, and I can't help myself but think, what if I just whacked on like a 1200 microfarad through-hole polymer? Probably wouldn't be a great idea, because then we've got legs upon legs of ESL, but uh, like obviously the connector isn't that bad. So yeah, I'm thinking, what if we added even more capacitance right behind the freaking core? Because this works surprisingly well, and it's just like more capacitance, more better. Um, Actually, I could probably just go for more aluminum polymers. Now I kind of wish I still had those 1000 microfarad tantalums. Like I have a bunch of 1000 microfarad SMD tantalums, and I ended up using them on a card, and they're like plasti dipped on, and I'm not like, I'd need to buy a bunch of plasti dip thinner to get that thing apart. So that's not happening anytime soon. Also, I'm not really interested in taking that card apart. Um, but yeah, if I still had those 1000 microfarad tantalums, then actually you can get even like 1500 microfarad tantalums, but those are so expensive. Those are like $4 a cap on DigiKey, which is just completely stupid. But like like that would, if I added those $4 cap, like I got this card for I think 30 quid. Yeah, around 30 quid is what I got this card for. Um Yeah, adding $8 worth of caps probably not worth it. But anyway, so yeah, at this point I'm thinking like I could add more capacitors to the reactor. This unfortunately does not work as well as I was hoping it would. This is probably just down to how far away it is across on the power plane, which kind of, yeah, like that sucks. But the connectors prevented me from getting it any closer. And the thing is, but like the reactor works surprisingly well. And I also decided I'm going to show you actual oscilloscope shots. So here is how the card. So this is a measurement. So the funny thing about these scope screenshots is that these are taken after I had already recorded my data. So they don't necessarily. So the results in these don't match the data because they were taken after the fact. Because I'd basically take all my measurements and then remember, wait a minute, shouldn't I maybe take an oscilloscope shot so that the people can actually see the thing? And so yeah, here's a scope shot. Because normally, like, all I really care about is the data, like the data that's in the data sheet. Like, I don't actually care about having pictures from the oscilloscope measurements. Like, I just want the minimum voltage to be as high as possible, and well, we can use a data sheet for showing that much. So there's the card without any capacitors. Then we have the card with the reactor. And you'll notice that this is actually measuring better than what I have in my spreadsheet. And the funny thing is like, so I took my reactor measurements first, then I took off the reactor, then I took my no reactor measurements, then I reinstalled the reactor. And after the reinstall, the reactor seemed to start working better. Which basically made me think, like, I decided ultimately not to record those results because that's bloody stupid. If the connector can, like, if, like, the angle or whatever of the reactor can affect the results. Um, yeah, but there's what the reactor does. And ultimately, it's not, like, massively better. It's about 10 millivolts peak to peak, but also the minimum is, like, 10 millivolts up. So I'm really like normal, like overshoot coming down a lot is pretty normal. That's easy. You just throw more capacitance and overshoot disappears, or at least most of the time. There are exceptions to that, but if you throw more caps at it, you can probably get rid of the overshoot. Undershoot, on the other hand, tends to not do so well. Like doesn't generally improve that easily. But yeah, this apparently was doing better undershoot, which I'm really annoyed about that. And these are all from Firestrike GT1, but they're also like taken in different parts of the test, which is why the waveform looks different. Because if you notice, there's a bit of a pattern going on in the waveform, and that actually correlates to the frame rate. And depending on which part of Firestrike you're in, the frames obviously cause different waveforms, and the rate at which the frames occurred changes how, like, the spacing of the pattern. So yeah. Anyway. Here we have the caps soldered to the card, right? So you can see that, and yeah, that's better. Like there's less peak to peak than there, but it's worse than this. And then we have the Reactor SLI, and that's this one. And yeah, that's doing really well. Actually, the maximum minimum in that is 1.16. Though maximum minimum is kind of like, that's kind of really dependent on the how many um the time scale. So, well, actually no, that's not dependent on the time scale. Peak to peak is the one that's really dependent on the time scale. Like if you have too short a time scale, your peak to peak will be really low. So that's like peak to peak's not a great measurement. Um, but yeah, absolute minimum and absolute maximum doesn't care about timescale, which is good. Um, so yeah, the maximum minimum being slightly up is like kind of interesting, but I like the thing is that doesn't matter because like what causes the GPU to crash is the voltage being momentarily too low or the temperature being momentarily too high, right? Basically, like, you might be looking at this and it's like, do 10 millivolts actually make a difference to stability? Well, yes, if you're, at a very specific combination of clock speed, voltage, and temperature, you're going to encounter instability, like you're not going to be stable. Whereas if you're slightly cooler or slightly higher voltage, you will be stable. So yeah, that's kind of the thing. Anyway, so that's it. That's it for this video. Is like the reactor is actually not a completely stupid idea. I'm very surprised by that. This actually works surprisingly well, and I'm really surprised by that because really like. I've always heard I've always heard this basically being considered a silly gimmick. But no, this is actually measurably better than not having the reactor. Is it necessarily better than having maybe a better PCB layout? I don't know. We might find out when I measure my GTX 770 classified, which has like, well, it has the standard issue, tin designed 14 phase monstrosity of a V-Core VRM with one of the most impressive output filters you could get for a GTX 770. So if that doesn't get better transient response than this, then obviously the reactor is actually a great idea. If it does, then yeah, the MSI should have just designed a better PCB in the first place, right? That's the problem there. Um, so yeah, and I'm really happy that I managed to squeeze all those extra caps on there and maintain the ability to like have the back plate. Like that is something that I was really sort of focused on with this was just like, well, actually any card that I have that's like a nicer card, if I'm doing mods on it, one of my sort of bonus goals for myself is like, can I make the mods not obvious? Because yeah, I mean, like it's better if you can't tell that the card's been abused. Well, it's not really abused. Like I'd actually daily this. This is actually like this by my standards is very neat. Yes, there's a whole bunch of extra solder on there, but that's just for extra current handling capacity or less impedance, in other words. um, but yeah. So that is it for this video, and so thank you for watching. Like, share, subscribe. Leave any. Wait a minute. Did I show you? I did show you the taken apart reactor, yeah. So, or that might have been in the previous take. I can't remember in that. I can't remember now. There's been 2 takes of this video. The first one I screwed up really badly. But anyway. So yeah, thanks for watching. Like, share, subscribe. Leave any comments, questions, suggestions down in the comment section below. And thank you to the patrons for obviously funding the purchase of this card right here. As well as like the oscilloscope and the test equipment I use. And yeah, if you'd like to support what I do here with the channel, then there's the Patreon. That's how I got cards like this, or the oscilloscope. And when I get the better oscilloscope, that's also going to be thanks to the patrons, because I kind of doubt that I'm going to be able to talk an oscilloscope manufacturer into just sending me like a review sample of a scope. That wouldn't just be ridiculous. Anyway, what else did I want to say? Right, there's also the HOC Teespring store, which does the exact same, serves the exact same purpose as the Patreon, except you get stuff in return, like shirts, stickers, posters, the usual YouTuber merch. So, yeah, that's it for the video. Thanks for watching, and goodbye.